Hello and welcome to another video. In this one we're going to be talking about writing a decorator for classes. And this is a question that I got on stream based on the protocol Runtime Checkable decorator. We're going to look at how that one works, and then we're going to write our own decorator that actually replaces the underlying class. I did another video on decorators a long while ago. I will link that one in the description, but that one's all about function decorators, so it's a little bit different. But anyway, let's jump into it. Okay, so for today, we're going to make a very, very silly decorator. Let's actually make a decorator here, and we'll fill out the arguments and the return value in a second. But we're going to use this decorator to decorate a class. And just to show that this works properly, we're going to give this class a docstring. And we're also going to, give it a method. Self print foo, for example. And what I want this decorator to do, and it's going to be silly, in this case we're just going to give this class another method. So we're going to give it, some foo method. And I'm going to show you how to do that with inheritance. You could do this by just attaching the method directly, but this problem I think is much more interesting when you do with inheritance. We'll show a decorator later that doesn't use inheritance, so we'll at least get both scenarios there. But this decorator here is going to act a lot like the function decorator in that it's going to take the thing that it decorates as its argument. So in this case, I'm going to call it CLS. This is going to be our class here. If we were typing this, although decorators are really annoying to type. If we're going to type this, we could type this as, type any, in that we're decorating a class here. I'm going to skip typing because the return value gets really messy for this one. But what we want to do is we want to replace this class with a new class. Let's call this class D. And I'm just going to extend this base class here and add our extra method here. So we're going to add a foo that does, print hello world, for instance. And then we're going to return this D class here. So this decorator is going to take in this class here, make a new class which extends that base class and adds this functionality, and then we're going to return this class. And if we run this, I'll show you one problem with this. Interactively run t.py. You'll see that we have our class C. However, it has this weird dec.locals.d. And in fact, if we look at C's name, it has the name D, which is our weird inner class here. Also, if we look at the docstring of C, it has no docstring. So we've lost the docstring, we've messed up the name, and the class representation looks really weird. And this is actually a problem with function decorators as well. And normally how you solve this is by importing functools and then doing functools.wraps and then telling what thing it's wrapping here. And, in an ideal world, this would work too for classes, but it does not. You get this mapping proxy object has no attribute update. And the reason for this is classes have a double interdict, but it's read-only-ish. And so it doesn't have an update method, and so functools.wraps doesn't work directly. You can, however, work around this, and if we look at the documentation for functools.wraps, by default it has two things that it does, well, three things that it does. One, it does assignments based on wrapper assignments, and two, it does updates based on wrapper updates, and the third thing that it does is it assigns double under wrapped, which is here. At least in Python 3. That way you can get back to the original object. And the problem is these wrapper updates are what's triggering this behavior here. But we can turn those off by doing, I think the attribute or the method is updated. Yeah, if we set updated to an empty sequence or an empty tuple, it will skip that dictionary update, this thing that's happening here. I guess it's not said, but the adder here is double interdict, and so that's why this is crashing. That's what's retrieving this mapping proxy. But if we set updated to the empty tuple there, now if we look at C, it looks like the original class. If we do c.name, we get C, and if we do c.doc, we get this original doc string that we get out. And of course, we can construct a C and call F on it, and that'll print foo, and we can call this additional method that we've added on here, and that will print hello world. If we were to debug this, which I find is often useful for showing how decorators execute, Let's actually just run this here. You'll see we're at our decorator. If we step in here, first we build the class. That's what this first thing did here. Next, we're going to call this decorator. Oh, actually, first we have to build the class, right? Now we will call our decorator. So you can see at this point, we're about to call our decorator. This is the original version of the class. So it already has, you know, it's double under doc, and it has cls.f. It has its f function, but we haven't put on that foo function yet. That doesn't exist yet. Next, we are going to build this secondary class. So we're looking right here right now. And if we step into this, we first return a wraps object for that base class. Now we build the D class, which is the subclass of this. And we build this function. And now we are inside of functools.wrap. So this is where the update wrapper call is happening. And if we look at updated here, we'll see that it's our empty tuple that we passed along here. And our assigned is these attributes here. So those come from wrapper assignments. And it'll loop through all of these and assign them over from our original class. And then eventually we will return out that new class D. And so you look at D now, and it looks like the original class C. But anyway, that's how you can decorate a class, and that's how you can write a class decorator. I don't think I've ever written a class decorator myself, so they get used very, very sparingly. However, I can think of at least three use cases of class decorators. One is to make data classes or adders classes. Another is mock.patch at a class level, which allows you to monkey patch for every method in that class. Although I find that one maybe a little bit tricky to use. And one that I showed in a previous video, which is the Runtime Checkable decorator in the typing module. I'm actually going to show you the Runtime Checkable decorator right now because it's simpler than this. It only performs a side effect and doesn't do any of this inheritance stuff. So if we do pydoc typing, we can look at typing.py, which is where Runtime Checkable is defined. And you'll see that it's defined here. It takes in a class similar to how my decorator does here, but you'll note that we don't do any special subclassing here. We just modify one attribute here. We set is runtime checkable to true, and that mutates the class that gets passed in. It also does some checking to make sure that it's, you know, a protocol and non-generic. But anyway, that's how this works. That's how class decorators work as well, and a way that you can reuse functools.wraps to implement the proper attribute forwarding for a class. Anyway, hopefully this was helpful. If you have additional things you haven't explained, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.